We will touch on some typical processes in an architectural world and how to improve them. There is a definite shortage of facade engineers in the United States, so I'm going to show you what you need to do for a do-it-yourself review of architecturals. Here's a page of a typical comments I sent on one project. These comments are fairly typical, and they simply say in summary that the project set is a mess, that it's impossible to glean the design intent out of those construction documents. And you would have obviously an upper hand if you had it reviewed in-house, because you know what the design intent was. And obviously it spares the embarrassment if the review was commissioned by the owner. One interesting part of this job is meeting big-name architects. They are very good in drawings and sketching, and their right brain side is prevalent, while I am 80% left brain according to some unverifiable internet tests. So there is obviously a big challenge in communication. Most glazing is delegated out to the design teams of subcontractors. Add to it the practical lack of design and specification on small projects with a hands-on approach practiced by many architects. And as these architects move up the ladder to larger projects, we have a scenario for a perfect storm. Some architects I spoke to no longer understand the word specification. In their mind, specification is something that a contractor provides to them. Today, design of a building skin is mainly an anticipatory engineering of interfaces among the delegated components which has not been designed yet, and this is a challenge. Add to it that in a typical scenario, your contractual obligation is simply limited to squeezing the owner's program into his budget, while maintaining a pleasant appearance, and the question of performance is seldom named directly. My goal today is to help you bridge this gap, and there are several steps that you can take. Most of the time and effort goes into the research, such as review of conditions, understanding and coordinating of the spacing and tectonics, interviewing consultants regarding aspects such as the amount of design movement or humidity, and your design eventually will be only as good as the underlying research. I hope we all agree that the universal language of architecture is drawings. It's very hard to hit a target you cannot see. We do need to draw all elevations and develop a glazing schedule. You wouldn't believe how many design sets that I see don't have even all elevations drawn. And you would have to do it anyway, sooner or later. If we are lucky, we get general fragmentary sections with fragmentary elevations where details and materials were chaotically assigned wherever there was a space on drawings. This is not good enough, but it's a good start. And here is how an architectural glazing schedule should look like. One page out of many dozens of pages. At some point you will be able to pick the glass itself based on its performance and visual aspects. And you can place it in a glass type schedule with all the respective glass makeups, reference on the glazing schedules. Our goal is to provide the future engineering teams of subcontractors with enough information so they can design this glazing for us. We need to provide them with design data and performance requirements, and it takes lots of coordination. While performance requirements come from your client's basis of design and respective code requirements, the design data comes from your engineers, from your consultants, and you need to collect it. What's left in architectural scope is interface details, based on your best guess as far as the anticipation of substitutions is concerned, and the absolute minimum is listed in the International Building Code. Components of delegated systems would require less drawing, while obviously interfaces would require much more density of information. Now on the right side you can see the typical European set. On the left side you can see construction documents from the average American set. An architect would be fired if they provided something like that in Europe. Now, how to recognize which parts here are architecturally designed interfaces and which are delegated? Where do we need to focus our attention? Now, I like to use a simple mnemonic technique. If you can assign a catalog number from a manufacturer's catalog to a component or a system, it's delegated. someone would or has already taken care of its design. Otherwise, it's most likely architectural and you need to better find this item in some catalog or hire someone who would design it for you or assign a team member to design it. So let's start designing it. Again, we cannot hit a target that we don't see, and therefore all plans and sections we have to trace the building envelope, which separates mechanically controlled from uncontrolled environments. You may need to draw a separate line of enclosure which would separate the dry from wet zones. There is a law of continuity. It says that whatever facade function you analyze and whatever building section, no matter horizontal or vertical or what scale you analyze, you should be able to trace all the functions continuously without any interruptions or offsets. Some people may use color crayons for that purpose. And there are 21 control functions of enclosures, which may be represented by different control layers. This list will be prioritized based on the project requirements, and we will trace those layers one by one. So let's start designing it. Again, we cannot hit a target that we don't see, and therefore all plans and sections we have to trace the building envelope, which separates mechanically controlled from uncontrolled environments. You may need to draw a separate line of enclosure which would separate the dry from wet zones. When we are done, we will find some confusing spaces which are perhaps not mechanically controlled, but it's ultimately your call whether you want to keep them inside or outside. Now here are some details that you may remember from the seminar on principles of facade engineering. Here we represent the facade function as a simple line, and we may represent its value, which is particularly useful whenever the value changes. Also helps to represent the differential conditions, which in turn tell us what about required properties of facade layers. Again, the law of continuity says that you need to trace it continuously, and you should be able to cross movement joints without destroying their functionality. Now, in order to cross and negotiate successfully movement joints, you need to find them and quantify the movement. Again, we cannot hit a target that we don't see, so we have to visualize it by drawing it on facades. There are 3 degrees of freedom: up and down, left and right, and on some projects back to the front. Your structural engineer needs to tell you what is the quantity of movement in those movement joints, and you additionally need to add the control joints to the equation. Only at this point you have sufficient information to be able to start drawing details. And by the way, congratulations! Some very prominent building enclosure consultants who showcase their work in textbooks never reached this level yet. Sadly, you would discover that most details that you used so far coming from manufacturing catalogs won't work. They are simply substandard. If you didn't draw it, you cannot expect to have it produced in the field, so your construction administrator would thank you. You will need to coordinate horizontal and vertical details so they can actually work together. At this stage, your main goal is to verify whether the depth of assemblies and their interfaces would agree with the modulation and spacing of facade that you envisioned. Requirements such as heat, noise and fire resistance may easily require changes to the slab edges, distances, structural sizes and so on. Whatever you do, make sure that your details cannot be used by a contractor as an ammunition against you. Some of the most frequent surprises coming in the submittal process relate to the thermal performance. Therefore, make sure that at least one person in your office can run the LBNL software. We already paid for this software out of our taxes, and it would be stupid not to use it to our advantage. Your interfaces most likely won't match the systems that would be ultimately proposed by contractors. Therefore, you need to specify testing to verify the performance. We need mockups or certificates of the lab testing, and we need the field testing. Only 5% of mockups pass their very first test. So unless you specify the testing and it went past successfully, your owners are going to end up with a substandard assembly that's going to fail. If you are a busy manager of architectural office with only so much manpower to go around, you will need to prioritize the risk and focus and concentrate on those areas which can hurt you the most. Joe Stibluck said the function of a parapet wall is to confuse architects. Here is the top of the curtain wall below a future coping. Do you see any problem here? The waterproofing membrane is meticulously adhered to the 1/8 inch wide mullion edge. Also, you don't want to over-rely on a sealant joint as a single line of defense that concentrates all facade functions and accommodates all associated movements. It will be interrupted at every corner and every vertical mullion anchor. Here is a coping termination to glazed wall, which has a flashing working the opposite way, and in addition to that, it's also unfeasible to produce. If you compound the challenge of transitioning and terminating your parapets and offsets with the issues of feasibility, you would probably end up with a high-risk assembly. It will be an assembly left unfinished, impossible to inspect, resistant to future attempts of repairs and inspections. Here is the recap of the main talking points, and that's all really you need to remember from this seminar today. Now, there is always going to be someone who would ask about the warranties. Warranties are for fools. They typically cover only a fraction of the total replacement costs, and they often take away from your right to sue within your statute of limitations. There must be a reason why the worst materials and systems come with the longest warranties.